You know when you're watching a sci-fi flick and there's this huge, epic explosion in space, the kind that shakes the whole theater? Ever stop and wonder, hey, wait a second, should it actually be making that much noise? Well, today, we're going to get to the bottom of that.
So yeah, that's the big question, right? Why is space just silent? It's totally different from what we see in the movies, and the actual science behind it, it's pretty fascinating.
Okay, so let's not bury the lead. Here's the big answer right away. Space is silent because sound needs stuff to travel through. You know, like air. And space, well, it's pretty much empty. No air, no sound. Simple as that.
Okay, so that's the what. But now let's get into the why. We're going to unpack the science behind that really simple idea. First things first, to really get why space is so quiet, we've got to take a step back and figure out what sound even is. Like, how does it work right here on Earth?
At its heart, it's actually super simple. Sound is just a vibration. That's it. Every single sound, I don't care if it's a pin drop or a jet engine, it all starts with something moving back and forth really, really fast.
But here's the thing. That vibration can't just teleport to your ears. Nope, it needs a ride. It has to pass its energy along through something, what scientists call a medium. That could be the air we're breathing, the water in a swimming pool, or heck, even a solid object like a door. The best way to picture it is like a line of dominoes. The first vibration knocks over the first particle, which bumps into the next one, which bumps into the one after that. It's this chain reaction of particles bumping into each other that carries the sound all the way from where it started straight to your eardrum.
Okay, so we've established that sound needs that chain of particles, that medium, to get anywhere. So, what happens when you just take all those particles away?
Right. Here on Earth, our atmosphere is like this thick soup of particles. They're all crammed together, just waiting to bump into each other and carry a sound wave. But deep space, it's the complete opposite. It's an almost perfect vacuum. The particles are so far apart, they almost never ever touch.
And that is the absolute key. If you don't have that chain of particles to pass the vibration along, the sound wave has nowhere to go. It can't even get started. The thing can still vibrate, sure, but the sound, it just stops, dead in its tracks.
I know this can sound a bit abstract, so let's make it super clear with a classic science experiment that shows this perfectly. It's called the bell in the jar experiment.
Okay, picture this. You've got a bell ringing inside a sealed glass jar. Step 1. With air in the jar, you can hear it perfectly, right? Loud and clear. Step 2. You start pumping the air out. What happens? The sound gets weaker and fainter and quieter. And then, for the final step, once all the air is gone, you've created a vacuum. You can still see the bell ringing like crazy in there, but you hear absolute silence. Nothing. That little jar has basically become a miniature silent version of outer space.
All right, so I think we've got the science down. But you're probably thinking, okay, but what about, right? This brings up a couple of really common questions, especially when it comes to astronauts and, yeah, those movies again.
So, here's a big one. If space is silent, how in the world can astronauts talk to each other when they're on a spacewalk? I mean, they're floating around in that vacuum, but we can hear them talking to Houston clear as day. What's up with that?
Well, the short answer is technology. Inside their helmets, a microphone captures their voice, the sound waves, and converts them into radio waves. And this is the critical difference. Sound waves need stuff to travel through. Radio waves, they're a different beast entirely. They're electromagnetic, just like visible light, and they have no problem zipping right through the vacuum of space.
Which, of course, brings us full circle, right back to where we started, the movies. And we've got to talk about what might just be sci-fi's loudest and most common scientific lie.
You guessed it, explosions. As amazing as it looks when a giant starship goes up in a massive fireball, in real life it would be totally, completely silent. You would see that incredible flash of light for sure, but you wouldn't hear a single thing. No boom, no roar, nothing. Just silence.
So, next time you're watching a huge space battle on screen, you'll know the secret. It all boils down to that one simple, elegant piece of physics. No air means no particles to vibrate. No vibrations means no sound. It's as simple and as quiet as that.